identities. So we learned the first 9 reciprocal identities, the 2 quotient identities, and the 3 Pythagorean identities. These are more identities, and so the first one, what we learned Friday, for those of you who weren't here, I sent the video, we learned the sine, sum and difference identities, and we also learned the cosine, sum and difference identities. Now we are doing the tangent, sum and difference identities. So you will have to memorize them also. To be honest, they're not really that hard to memorize. They're just a little tricky thing that you have to think about. The whole point in these 3 identities, both the cosine, sine, and tangent, sum and difference identities, is to get exact values when you are given some sort of angle that is not on the unit circle. The only exact values we know are the values on the unit circle. Otherwise, up to this point, we've had, if it wasn't on the unit circle, we plugged it into our calculator and we got a decimal approximation. Well, you can use sum and difference identities to get exact answers for values that are not on the unit circle. And that's what these are for. Okay, so in this case it says find the exact value of tangent of 75. Is 75 on the unit circle? No. So they want us to find it using 2 angles from the unit circle whose difference is 75. Now, if it were me and they had just put up there tangent of 75, find an exact answer, I would have used 30 and 45 and added them together, because 30 and 45 is 75, and that would be easy. But they told us to do the difference. So we have to use some other angles instead of just quadrant 1. So.
Do you 90 minus 15, or do you have to use
15 isn't on the unit circle.
Okay.
So you can't use 15, because we don't know 15. Now we figured 15 out the other day, but you don't know 15 right off the bat, because it's not on the unit circle. So I have to use 2 other values and do subtraction to get 75. So I do know this. I can't use 90 because I don't know 15. So I'm going to have to go past 90 and use something in quadrant 2 with something in quadrant 1. So you got to know, what are the values in quadrant 2? What's over there? What's the first one past 90? What's after 120? 135. And what's after that? Okay, so think about those and what can I subtract?
120 minus 45.
What? Wait.
Wait, it's 135?
No, 120 minus 45.
Yes.
Wait. 120 minus 45? Will that work?
Yeah.
Okay. Yes?
Is 135 also?
135.
So you do 135 minus 60.
You could do 135 minus 60. Okay, so we have 2 different options. So let's write down, just real quick, let's write down our ordered pairs to figure out which of the options might be easiest. Okay, just the ordered pairs. So first of all, what did we say our first option was?
120 minus
120
45.
minus 45. So I'm just going to, over here on this side, and we're going to use them again in a minute anyway. So I'm going to write 120 and my ordered pair for 120. Okay, so what is your ordered pair for 120? What angle does it line up with?
60.
It lines up with 60. So the ordered pair is the same. The only difference is the positive negatives. So it's this one.
And square root of 3 over 2.
So it's a half and square root of 3 over 2, but it's in quadrant 2, so your x value is negative. That's 120. 45 is the easiest one. 45 is square root of 2 over 2, square root of 2 over 2. We like 45. Or I could do 135. Well, that's the same thing as a 45-degree angle. So it's square root of 2, square root of 2, but the x value is negative. Minus 60. Well, essentially this is doing the same thing. It doesn't really matter. Right? Because these are about the same values. Doesn't really matter which one you do. Because if you look at it, they're pretty much the same thing, isn't it?
Yeah.
I mean,
The
they're
only
just...
difference is the square root of 2 is negative instead of 1 half.
Yeah, so they're just flip-flopped positive and negative signs. So it really doesn't matter which one you choose. They're probably going to be about equally as easy or equally as difficult, whichever way you want to look at it. So I don't really care which one you do. Which one do you want to do? 135 and 60?
I was going to say 135.
Do you want to do them both? Oh, you get the same answer no matter what you do. I don't know what to do with my blue pen. Okay, so I'll do 135 and 60 and then I'll do the other one. So if I do 135 and 60, now remember in subtraction order does matter. So I'm looking for a tangent of 75 and I'm getting that from tangent of 135 All right, so now at this point it is just plugging numbers into the identity. So this has to be my A, this has to be my A, and this has to be my B, because order matters with subtraction. So I'm using the difference identity over here on the right hand side. So it's going to be tangent 135 minus tangent 60. Alright, now we got our x and y values over here. We did not get our tangent values. Tangent, remember, is y over x. So, we're using these two right now. So I have to figure out what tangent of 135 is. I have x and y here. Oh, that's easy. 1.
Well, would
Okay.
it be negative 1? Or would it just be 1?
It would be negative 1. So let's see, negative 1 minus, what about tangent of 60? Anybody remember it off the top of your head? Tangent of 60? It lines up with pi over 3.
Oh, it's just square root of 3.
Square root of 3. So I get 1 minus the square root of 3 over 1 minus the square root of negative 1 minus the square root of 3 over 1 minus the square root of 3. Because it's a negative 1 times the square root of 3 on there. That's it. Easy enough. That's the exact answer for tangent of 75. You want me to find it the other way?
Oh, like using the other.
Using the other values? We So we could do tangent of 75. A tangent of 120, remember 120 is opposite of 60, so the tangent value is still square root of 3, it's just negative because it's in quadrant 2. So I get negative square root of 3 minus 1 plus same thing. Either one works. Alright, so we're going to do the same thing for the value, the next one, value 165, tangent of 165. Now let me tell you this, in this case, there are also two choices you can use. One of them is definitely easier than the other. So let's look at what our options are and then let's do the easier of the two. Yes, sir?
Would we have to rationalize this?
Technically, yes. But no. But technically, yes. But I'm not going to keep it. Because do you remember how to rationalize something like that? You remember? You have to multiply by the conjugate. Because it's a binomial down there. So, we're not
So
going
1
to
plus
it.
square root?
Mhm.
So 1 plus square root?
You'd multiply both the top and the bottom by 1 plus square root. Okay, so in this one we're going to find the value of tangent of 165, and it tells us specifically to use a sum. So again, I'm going to be using other two values, probably using something from quadrant 2 to get 165. So what do you think?
120 and 45.
120 and 45, which I already wrote my order pair down here. Or I could do 135 and 30. So I'm going to write 30 over here because that's the only one we don't have. So 30, that's this one, order pair, square root of 3 over 2.5. Okay, so we already said what tangent of 120 was. So I'm gonna just put it right here. Tangent is square root of 3. Tangent of 45 is 1. Tangent of 135 is negative 1. Tangent of 30, square root 3 over 3.
Can you speak the paper a little bit?
Okay, so now I could use either one. I'm going to write them both down and then we'll look and see which one we think is easier. So I could use tangent of 135 plus 30, or tangent of 120 plus 45. Why?
Because they all have the same number.
Good. That's a good way to look at it. They all have the same denominator. And my main reason for
There's not a
there's
fraction.
not a fraction. Tangent of 30 has a fraction, whereas all of these are whole numbers, no fractions. This is a fraction. I'm trying to stay away from. I mean, I like fractions, but y'all usually don't. So I would stay away from this one, and I would use this one. So let's see. So this is A, this is B. Since we already wrote everything out, this is actually real easy. That's it. Since we went ahead and figured all our tangents out ahead of time, easy.
Wouldn't it be negative 1/3? Because it's 120.
Oh, yes,
negative
yes,
1/2.
yes, yes, yes.
So
That should be negative.
it's
120 should be negative. And this should be plus, because that should be negative. You're right, thank you. I should have put that over here. It's in quadrant 2. This one's negative. No, it's not. I did put this in. Okay, so now at the bottom of the page, this little number's taking us, we're going to be using the sum and difference identities, you can see right here. But before that, we have to set these up. It says suppose sine of theta is 3 over 5, and sine of alpha is 5 over 13. Additionally, tangent of theta is greater than 0. What does that mean? Tangent of theta is greater than 0. It's what? It's not negative. So tangent has to be positive. Okay. Tangent of theta has to be positive. And then tangent of alpha is less than 0. So it has to be negative. So it says draw angles theta and alpha, label your reference triangles, and then find the values of sine theta plus alpha, cosine alpha minus theta, and tangent of theta minus alpha. So I'm going to give you a minute to set them up, set up your reference triangles, and then we'll walk through the sum and difference part of it together. Let me give you a second to set them up. Go. Set up. quadrant 1.
They're not positive.
Because everything's positive, both sine and tangent are positive, and the only place that happens is in quadrant 1. So then I just set it up, and sine is 3 over 5, opposite over hypotenuse, so that's 3 over 5, which makes this a 3, 4, 5. So I just put it 4 there. Then alpha has to be in quadrant 2 because it said our sine value was positive. So 5/13. The only place where sine is positive and tangent is negative is in quadrant 2. So that's why it's there. 5 over 13, it's also a Pythagorean triple. I'm not sure if y'all know that one, but 5, 12, 13. If you didn't, you could have just used Pythagorean theorem and actually found it to be 12. It's negative 12 because it's in that quadrant, so it has to be good. Okay, so now with all that in mind, I am now going to use my sum identities. I'll do sine first. And it's just plugging in values. So remember the sine identity, it's on page 1 if you don't remember it, but it groups sine and cosine together. So it's going to be sine of theta cosine of alpha plus cosine of theta sine of alpha. Well, I already know what sine of theta is. It's 3/5. Cosine of alpha, I'll just go over to alpha and I'll figure out adjacent over hypotenuse. Cosine of theta is 4 over 5. I just go to the theta and I figure out adjacent over hypotenuse. Sine of alpha is at the top of the page. I can figure it from my triangle too, but it's already given. Now it's just computation. So got negative 16/65. Cosine alpha minus theta. So this is the cosine difference identity. Now the cosine identities, you group the cosines. So it's going to be cosine alpha, cosine theta. And the sign is backwards. Whatever's in here, it's the opposite of the actual identity. Now I'm just pulling values from my triangle. Or I'm actually pulling them from the problem above. I already looked them up. Last is a tangent difference identity. It's at the top of the page. So I'm going to my triangle. Tangent is opposite over adjacent. Okay, now, I need to subtract across the top, so I need a common denominator. So it's going to be 12, so I'm going to make this 3/4 into 9/12. This fraction is negative, because that negative 12 on bottom, so I have a minus a negative, so I'm going to make it plus 5/12. Is everyone okay with what I just did to the numerator? I haven't touched the denominator yet. Alright, I'm going to do this in 2 steps so I don't lose anybody. On the bottom, I just have to multiply across, so I get negative 15/48. So now the bottom needs a common denominator. So on top, I got 14/12. On bottom, I'm going to change that to 48/48. Alright, compound fraction, you gotta keep switch flip. 14/12 times now 48/33. 12 goes into 48 4 times. So I got 56/33, so my brain's moving faster than me. 56/33, which does not simplify. Everybody kinda okay? Computation is just computation. So that part of it, we've been doing that kind of stuff since, I don't know, 8th grade or so. Maybe not keep switching. Yeah, you have to keep switching. Alright, so now on the back, now we're actually going to they are identities. So now we're going to actually use them like identities, just like we were using all the other identities. So I am going to try to make the left side look like the right, because the left side is the one that has the tangent sum identity. I'm trying to make it look like this right-hand side. So the tangent sum identity, the tangent identities, they have whatever sign is in the middle, that's the sign that's on top. But on bottom it has the opposite sign. So this is going to be 1 minus on bottom. Okay, now there's nothing that I can do to tangent of x, because x is an unknown value. So I'm going to leave tan x. But I know what tangent of pi over 4 is. What is tangent of pi over 4? 1. So I have the same issue on bottom. Tangent of x can't do anything about that, but tangent of pi over 4 is 1. Okay, so now I have tangent of x plus 1 over 1 minus tangent of x. Huh. Well, look at where you're headed. What should I do? Change tangent. So I'm going to change tangent to sine over cosine. Okay, now this is something that I noticed when I was grading the quizzes. Some of you get lost when you have compound fractions. Like what happens is you have to do all this work for the numerator, and so you do all this work in the numerator and you completely forget that you have a denominator. So what I'm going to do to make sure that we keep track, I am going to highlight my numerator. So it was tan x plus 1. That became sine over cosine plus 1. That's 1 minus tan x. It became 1 minus sine over cosine. Everybody with me? Okay, so I need to fix the numerator. The numerator needs a common denominator. So I'm going to make it sine x cosine x plus cosine x cosine x. That's just the yellow. I have done nothing to the blue yet. So now I have to do the blue. Everybody good so far? Okay, so I'm going to move up to the top page. I'm going to simplify. The yellow has a common denominator now, so I can actually add. When you add with a common denominator, the denominator just stays, cosine x. So now it's going to be sine x plus cosine x over cosine x. That is what the yellow just became. That was just the yellow though. Now I gotta do the blue. Okay, so now I have a fraction on top divided by a fraction on bottom. Keep switchblade. So sine x plus cosine x over cosine x. So I'm keeping the yellow the same. I'm changing the division to multiplication, and I am flipping the blue over. Now what happens? Your cosines cancel. You multiply straight across, I have sine x plus cosine x over cosine x minus sine x, which is the same answer. Yeah. Everybody okay? Alright, so now with the next one. So I have tangent of pi over 2. Where's pi over 2? Straight up, right? What is the ordered pair up there?
0, 1.
0, 1. Okay, so if that's the case, tangent of pi over 2 and pi over 2 is 0, 1. Okay, so what is it? What is 1 over 0? Undefined. Now, that would be an issue. But they're telling me it could be cotangent on the right, so here's what I can do. Since tangent of pi over 2 goes undefined, instead of writing it as a tangent, I can write it as sine of pi over 2 minus x over cosine of pi over 2 minus x, because neither one of those go to undefined at pi over 2. So, okay, so now that's what I'm going to do. So I'm going to do the sine sum identity on top, and the cosine, the sine difference identity on top, and the cosine difference identity on bottom. So I'm going to give you a second. You try. It's pretty easy. Yes.
So I was looking for all the notes, and I have nobody's reading through today.
Tell me some of them are partially done.
Yeah,
Okay.
there's some, and like there's one of them where I was like, I'm gonna do this. I'm really gonna do this one. And then I realized I was doing it wrong, so now I stopped. But I mean, there's a few my name. Maybe not even the date, just.
If we know that sine pi over 2 is 1, we just substitute that whole thing for 1.
But it's not just sine of pi over 2, it's sine of pi over 2 minus x. So no, I guess, is my answer.
I don't think that's right. I'm looking at this problem here, and my answer is literally that. That doesn't sound right.
Yeah, that's probably not right.
Like, feel free to dump.
What is speed? Okay, what is p? What is it telling? Position. And then what comes next? How's it go?
I just know velocity, acceleration.
Okay, so it goes position, velocity, then acceleration.
Oh, okay.
So position's the first, velocity is the first derivative, and then acceleration is the second derivative. What is speed? Is that position? Does speed have anything to do with position? No. So which one is speed? Speed's another name for
Acceleration?
velocity.
God dang it, Mr. Roy is killing me.
Velocity is just speed with a direction attached to it.
That's
So-
disgusting.
So when they say the speed, you need to be using the first derivative.
That kills me. Okay, so I came here to suffer. I tried getting related.
Okay, so sine of pi over 2 cosine x plus cosine pi over 2 sine x, sorry, it should be a minus. This is a difference identity. That's just the yellow. Blue, my cosines stay together. So cosine pi over 2 cosine x minus sine pi over 2 sine x. Alright, so sine of pi over 2. What is sine of pi over 2?
Sine
1. So that'd be 1 times cosine x, which means on top I have cosine x. What is cosine of pi over 2? 0 times anything is 0, so that's all that's left on top. And on bottom, cosine of pi over 2 is 0, you just said. And that would be minus, oh sorry, it's cosine, that's a plus. So sine of pi over 2 is 1 times sine x, so I get cosine x over sine x, which is cotangent. Is that easy? Where'd I lose you?
Why is there cosine on the top if you're distributing sine out?
You are not distributing. Remember, okay, were you here Friday?
Yeah.
Okay, remember distributive prop,
Okay.
we're using identities.
Yeah, I was lost on like, just like from that step going on. I wasn't gonna distribute, but I knew that I didn't really know what to do. Okay.
So like how do you do it?
I plugged into these, this is my,
How do you know which one to use?
Okay, I get it.
because it was minus. If you look at it,
Oh, okay.
it was minus, so you have to use the difference in it.
Okay. I see.
Because it was, there's minus.
And
so
like
there's
on the one
minus.
before we used the
This was plus,
additional.
so we used tangent plus.
Okay.
Okay, so try the cosine at the bottom. It is easier than easy. It's easier than the one we just did, which I thought was easy, but this one's even easier than that.
Wait a second, what's even confused? Nothing new. Your friends were here for you when I turned and there was no one there. I told her they were opening the door. She
That is
stopped
funny.
listening.
Right? And no, like you just, I looked and I registered that there was no one there and you're like, they're opening the door like after the fact.
Alright.
Okay,
Oh man.
so just plug into the identity. We just said cosine of pi over 2 is 0, which means this whole thing's is gone. Sine of pi over 2 is 1, and 1 times sine x is sine x. That one was easy. All good? Alright, so the bottom of the page, it says to, it's right here, Dan. It says to do, use the cosine sum and difference identities. So we're using both down here. Cosine groups to cosines. Alright, 3 pi over 2. What is the ordered pair at 3 pi over 2? 0, negative 1. Okay, so this first one, cosine of 3 pi over 2, that's 0. So that means this whole first piece is gone. So I got sine x left here. This whole piece is gone.
Well,
This
it's
is negative, sorry.
Yeah.
This is negative 1. This is minus negative sine x. Right? Because this is negative 1. So now I have negative sine x plus sine x.
Wait.
It should be plus negative sine x plus negative sine x.
But this minus
He's talking
minus.
about the one in the
I was talking
middle,
about
but
this.
two
There's
over
another
there,
one.
though, too.
Because there's a negative minus. Do you want me to make
Because it's
parentheses?
minus and negative 3.
Or I probably should have made another set of parentheses. What, I should have done a line in between there. Is that, do y'all need me to do that? Because I did kind of skip a step. I really did skip it though. I probably should have. So it's 0. Okay. Alright, so. Now, on several of them, there's more than one way to do it. Sometimes the two ways to do it are equally as easy / equally as difficult, whichever way you want to look at it. And sometimes one of the ways is much easier. So I would look at them and try to figure out which way is the easiest.